Alright, so in this video, I'm going to solve the equation x to the power of x is equal to 100. So, before we even start the solution here, let's just start with plugging in 1. So if I plug in 1, I get 1 as a result, because 1 to the power of 1 is equal to 1. Now let me plug in 2. I get 2 to the power of 2, which is 4, which is nowhere close to 100. Let's do 3 now. I get 3 to the power of 3, which is 27. So we're getting a little closer. Now, what about 4 to the power of 4? This is equal to 256, and this is more than double of 100. So we know our solution, x, is going to be somewhere in between 3 and 4. It's going to be a decimal value. So now that we know that, let's go ahead and actually solve for the value of x. So I'm going to first start by taking the ln, or natural log, on both sides. So I get ln x to the power of x is equal to ln of 100. Now, if I have something in the form ln of a to the power of b, this is the same thing as b times ln a. I can move this b to the front. So I'm going to do exactly this to ln x to the power of x. So now I get x times ln x is equal to ln of 100. Now 100 is the same thing as 10 squared. So I have x times ln x is equal to ln of 10 squared. And now I can move this 2 to the front, again using the same property. So I get x times ln x is equal to 2 times ln 10. Now, if I have something in the form e to the power of ln of k, this is equal to k, because the e and the ln cancel out. So this means that e to the power of ln of x is just equal to x. So what I'm going to do is rewrite x as e to the power of ln of x. And I'll tell you why in just a second. So the reason why I did this is because now I can use the W-Lambert function. And what the W-Lambert function states is that if I take the W of something to form a times e to the power of a, this is just equal to a. So in this case, I have ln x times e to the power of ln x, and we can think of ln x as a. So this is in the form a times e to the power of a. Meaning, if I take the W on both sides, and I have to do this on both sides, I'm left with just a on my left-hand side, which is ln x. So I get ln x is equal to the W of 2 times ln 10. Now I'm going to take e to the power of both sides. So I get e to the power of ln x is equal to e to the power of the W of 2 ln 10. And remember, e to the power of ln x, the e and ln cancel out. So I'm left with x is equal to e to the power of the W of 2 times ln 10. Now from here, to find the exact value of e to the power of W of 2 times ln 10, I'm actually going to plug this into a calculator because there's no way to actually calculate this. And if I plug this into a calculator, I get x is equal to 3.597. So this is my solution to this equation.